I interrupted last time up to what I thought was a logical shift from one of the what do you call points regarding the very basics of what is solid modeling and what is surface modeling. And then the feature which I wanted to outline is that a solid generally has weight, a volume, all properties related to a volume will be there in the, all properties related to a volume will be there in this. However, what is visible to you is the external surface. So, in generally whenever you see, especially if you see our for example, if you see all the games, what you see is obviously what is outside, and only when physical properties are attached to it, then things like motion of waves and physics of acceleration, deceleration and stabilization and how things move, in those points the solid properties become visible. However, games and those things are very, very different, as you have noticed. Even the Vice City will not play as well as an ordinary computer, and then if you need to buy a proper game, you have to buy their console, otherwise you are lost. That apart, let me start with the very, very big basics. Have a look at the my working what you call computer. Here I would like to prompt you also saying these things have been prepared with software which all of you must have heard about it, but any software is okay. I am not endorsing saying this software has to be here or anything, anything is just fine. Now, the very basic solid which you can talk about, as it is when you are looking at it, you will notice that on the face that is facing the light strongest, the reflection is best, and the face which is, if you see this is a little bit in the darkness. So, here you will notice that there is no, it is dark. So, one of the very, very important properties is the way it reflects light, and the type of reflection and all determine various things. And further related to these things is that you have a face here, you have a face here. When these two faces join together, you have an edge. And since these are all real life, your own experience thing, your I do not want to use the word your brain and you separately at this point, you will be able to perceive that it is a closed solid, though you are not able to see the other three faces, it looks, I will say, good enough. Now, see some small difference, there is a highlight which is catching it. So, this highlight is the one that makes things, you see here no highlight, looks dull. The moment you add this highlight, suddenly things will become a little more clearer. Now, this is the same cube, the centers of some of the edges have been joined together and we have ended up with this. Out of the 12 possible edges, 4 on top, 4 on the bottom, 4 all around, if you just take the midpoints of 6 of them, you will end up with this very interesting object. This is a hexagon, and if you actually if you measure everything correctly, we can even make a perfect hexagon with it. Now, we come into the important aspects of saying what is a surface, what is a solid. If you have to take a, Again, once again you see here that highlight has been created here, and this is where all your rendering software will make the object look real. Notice here, first of all, the hexagonal part is something that has been added. When you actually cut it, first thing you will notice is that it's empty, there is nothing inside. So, depending on the complexity of the the software, depending on the utility of the software, you will be able to make out how well it is represented there on top. And why is it part of this? Finally, again coming back to the original Sarma is saying, all this is available to you. You can get it free, or if you can pay for it, you can maintain the thing. And if you are part of a organization, I am sure you generally have some sort of 3D object suits, and so many of them are popular. You yourself can check in your region what it is. One of the things you will notice is, have you seen that this has been intentionally, this highlight has been created intentionally. That is the one that makes it look a little more natural and real. Now, when we want to actually make this cube, it is possible just that we take all the 6 faces, glue them together. I will crudely use the word glue, with or without tabs, and you have this object with the least amount of trouble. But then you were expecting, when we actually cut the solid, our normal thing will be to expect that something like this will result in this, which is, well, it is good to think about it. A genuine full solid modeler has the provision that if you slice a solid, you get this, and full fledged sculpting is possible. Followed no full fledged sculpting, meaning we can create objects which are real life objects, including that mouse which I showed you, or these are a very ordinary thing which can probably at best provide us some simple thing like this. These are all, there are certain geometric primitives that are there. In the case of pure geometry, we all know about the line, circle, arc and ellipse and so on. Equivalent to that, while the similar lines, everything are there in most of the packages, you have them at 3 levels. One of the first level is the basic lines and curves. Second level is surfaces. And the moment you come into a surface, you come into other issues about it, saying how can a surface be curved. So, if I take, I am just taking things which are around, I have this mouse pad. For practical things, it is a surface for us, you and me, but for a computer representation, it is not enough for us, because the moment it becomes a curved surface, life has become very, very complicated. You have seen this, and this is where concept of geometry and meshes will start. If we have a flat plane, all the points in this are coplanar, and by definition any number of points can exist, but let us say in space you have 3 points. A plane can easily exist through the 3 points, a unique flat plane can exist there, but the moment a 4th point comes, if you take the 4 corners of this, moment a 4th thing comes, we may end up with a 2 elemental triangles joining together and forming a something else. This is how all mesh generators, everything start, and lot of the things which we assume including shadows all depend on that. Say from here this has been cut, something has been done added and we have come so far. Now this I have explained to you already, we have this edge, this was the starting point. Now I go back a little and then get back to the package and saying, imagine I want to make this object, do not ask me what it is. To make it interesting, I wanted to show you that if you have a corner of a room, we can probably have a speaker device like this. Why can't we have a speaker? I will now go around looking around for a two-way speaker system, and to make it convenient, I will see whether I can have a baffle ported enclosure. So, what you saw there was my earliest attempt at a baffled ported enclosure. We have a, on top we have a circular port. Advantage of circular ports is a little bit of the rules are known, and then here I have a triangular port because it is easy for me to follow these corners, and there is something halfway between that and this saying. I can save a little on the surfaces by using one of the corners of the wall. All I need to do is put only one arc of a surface, open it, and then I have a beautiful ported enclosure. So, let me go out and then I have these beautiful speakers. At the moment, let me not talk too much about it, except saying that I need to have mounting, and they are coaxial and probably quite powerful. You see them occasionally in cars, and then home also you can there. Now, just to keep your what you call, to hold your attention. So, this is probably the speaker and this is the grill on it, saying, can I now make something, and let me go here and start with looks good. So, I will see how best to create it. I will start with a absolutely new object. We start with a corner. My basic box is ready. This is where I wanted to tell you this, it probably it helps if you are familiar a little bit with the normal geometric drawing, or specifically if you are a machine drawing expert. That is the reason why I brought those other two, what do you call that, pipe and so on. So, when we start here, let me attempt to cut this and see what will happen. Good enough. I have a cube in which parts of it I am removing. This is where I thought I will show you just how the This is what I have been mentioning all along. We end up with very, very peculiar hollow devices, and I will try to undo, go back and say the hexagonal cone thing has been done by a very edge 1, edge 3, edge 4, edge 5, edge 6, and I pass a curve through this. I have practiced this, I have rehearsed and practiced it. In this, I have a beautiful hexagonal appearance here. This is a little bit of the, as I say, drama built into it. Do not be too upset by the drama. So, you see here that now, as I explained before, I try to make it into a surface, because that seems to be the easiest way of. I select an object, I use this for splitting. In this, see, what has happened is, as I have shown you before, I have ended up with this empty what do you call box like thing. So, I still have that elemental that hexagonal the plane, this is available. So, I will instead hide this. Now, this is the object which I was looking to create in the first place. Can you see this? Just to keep your attention and interest holding, I thought I will make something useful. As I said earlier, it is possible for me, for example, to make a tube here, so that the tube can be used for porting. And if you are one of those audio enthusiasts, you will probably, it is very much possible for you to, if I join all this together and make it into a this thing, this has become a full fledged solid now. You understood? It has become a full fledged solid now. Now, at this point, I can do various operations, including I can cut it, I can make openings in it. Just for a start, let me see, this is the basic Boolean that is possible. Now, I will make a proper Boolean that can be done. So, looking here, I will know that I can make a small cylinder, so that I can use it for now this cylinder goes in here. I had finally made, you have seen this. So, I have a what do you call something, a solid which is intersecting. I can have this speaker just sitting there, and by various manipulations and all that, it is possible for me now to go ahead building things out of it. Just to see if I can do something else. See, we have one face here. It is possible for me to make a solid out of this. For the first time, I now have what I consider it as a slightly improved version. In case I want, I can have it sticking around like this, or if you remember the first time when I showed you that I had made that very peculiar ported enclosure. This particular one can sit in the corner of a room directly in front of you down, or in the corners of the 4 corners of the room. The issue being, now if you look at a regular practical speakers, and you see this corner speaker element, see that there is a beautiful cut there at a reasonable this thing, and this is how exactly these things are produced. So, there is a corner, something goes into a corner, and if you see carefully, in real life, this is the standard geometry of most of the objects that we see there, and miraculously for us, see that, and you see the small opening at the bottom, and if you go here, in fact, if you go to this type of an object, you see there all the complicated things are all still built around basic geometry. So, the corner here they have left a small gap here. So, the top is used as a horn and the bottom is used as probably the ports for the reflex what do you call bus reflex ports, and inside if you go back and check the inside, probably there are enough designs, anything you can think of, probably somebody has thought of it, and you can have huge amount of these items. At least this time I got it a little easier. You see here typically this is what I thought now, I will try to show you in the first instance, and you will notice that this is with the port or vent which is there. So, it is possible for us that you can carry out 2 types of design. One is the geometrical design, one which the volume and those things are calculated. Another is the mechanical things, especially the baffling and all that, using your simple basic layout of a equipment. In the case of an equipment, as I said, generally most of them end up with a rectangular parallelepiped, but in the case of the speakers and all that, the same thing still involves huge amount of calculations, huge amount of, you see here, and these days, while once upon a time they were very, very complicated, now instead of just leaving something just like that, they have something here which is a little tuned to both the volume here, both the characteristics of the volume and how the standing waves may get affected, and a very similar thing which is there on top comes here, and you have a beautiful this thing. The second part of it is invariably any of the these things involve calculations, and in calculations most important probably first thing is the volume, and if you have access to any solid modeler, calculating the volume is very, very easy. Similarly, all the geometric path of each wave is easily calculatable using those things. It is nothing, this is that one of those what they call ports. This is probably tuned, and in the first prototype somebody has done it. Afterwards you just have to fix it in each of them, and these are all the smaller things, likely that you may have it. There is a little more bigger professional device, while these calculations what I talking to you about has about a small standalone thing in one corner. Now if you have a big auditorium, and if you have, or even if a big hall, the way the sound propagates, the way the what do you call signature of the the whole auditorium is generated can easily be done by geometric modeling. And if you have a proper what you call equivalent seen this here, the port is on top. This is what I had attempted to do there, maybe a little unsuccessfully. So, with this stuff it is easier with us to go on making very complicated these things here. So, if you take any of these what do you call these designs, we have beautiful speaker plants, and it is up to you to see how well one can build these things. I am very much, even today I am fascinated by this. This is what is the ported with baffled enclosure. So, you see here, see this, we have something here, and then this thing node comes out, and there is something which comes back, and all this which can easily be made by a software. And like all software and all physical phenomena, the ultimate thing is your experience or the user's experience. So, somebody makes all these things, and then should they, how rigid should this be? Should the walls be rigid, and should there be some damping that is provided? How much of damping should be there? All these things, it is relatively easy for us to predict, but for the basis of all that prediction is you need a solid model. So, what I have shown you is a very simple solid model, but not surfaces which you see in your car or which you see in your clothing. And two of the best examples are, I am sure as a child you would have tried to make a globe, a terrestrial globe. So, a terrestrial globe, easiest way is to probably take another ball like thing and then add something and make it like this. Alternatively, next best is your soccer ball, which is made of hexagons and pentagons. So, if you go and check how many hexagons, how many pentagons, how to make it, that is easy way. Now, why I have mentioned this concept of a curved surface and why this ball with hexagons and pentagons? A hexagon and a regular pentagon are again made with equilateral triangles, which is the basis for all surface modeling. A small triangle is the basis for all surface modelers, and that is the mesh which on which things are very much built up. So, I will say, I will of course, I will make it a lot more in detail later. You see here in several of these Mathematica programs and all that, the starting point is a icohedron, that is, I mean sorry icosahedron that is where these triangles are all assembled together and something which becomes a beautiful thing like this occurs. And then this is where, including things like our famous buckyball and everything on any structure, in this, it is a question of granularity or the resolution, and then you have these triangles, and then in one face if you see 5 of them will be making a pentagon, 6 of them will be making a hexagon. So, you go around and search on the net, which I will try to show you. It is even possible for you to make a ball by taking a printout from an A4 sheet. The hexagons, these things are all attached to this. So, I will continue with this in the next session. So, until then, my suggestion is go to the internet, or if you already have something, try to download some 3D modeling package and see if you can print out simple 4 triangles, 4 equilateral triangles, and then by attaching to them you have a prism, and you can also make sure that those things are all attached together without being a discontinuity there. So, thank you. I will continue next time.